Hello everyone, I am Dr. Haseen Ahmed and you are watching Chemistry with Dr. Yousafzai YouTube channel. Today we will talk about Biginelli reaction. It is a three-component reaction in which aryl aldehyde, 1,3-dicarbonylic functionality and urea react with each other in the presence of acid. When these three components react with each other, it resulted in the formation of pyrimidone ring. This pyrimidone rings is very important in pharmaceutical applications. How these three components react with each other in the presence of acid. To completely understand the mechanism of this reaction, let's have a look to the reaction mechanism, that how these three components react with each other in the presence of acid to produce pyrimidone ring. In the first step, different aryl aldehyde when used, it will be protonated in the presence of acid. So here benzaldehyde is used, so benzaldehyde will be protonated and positive charge will be appeared on oxygen atom. If we talk about carbonylic functionality, it is electrophilic position. This is electrophilic position. And when this carbonylic functionality is protonated, it becomes much more electrophile. So whenever any nucleophile is present in the reaction mixture, then nucleophile will attack at this carbonylic functionality. And in this reaction, the nucleophile is urea. The nitrogen atom of urea has lone pair of electron, so due to this reason what will happen, nitrogen atom will attack at carbonylic functionality of protonated benzaldehyde. And as a result, the bond between carbon and oxygen will break toward oxygen atom and carbon and nitrogen bond will be formed. So what will be the charge on this nitrogen atom? Positive charge, because this nitrogen atom form 4 bond. So one of the hydrogen atom will be removed in the form of proton, and this proton will then be gained by this OH functionality. So I will combine both of these steps in single step. It will be converted into OH2, so oxygen will get positive charge. And if we talk about this OH2 functionality, now this the OH is converted into OH2. Due to this reason, this OH becomes good leaving group. In the next step, this OH2 will be removed in the form of water molecule, so it is dehydration reaction. And when this OH2 is removed in the form of water molecule, the bond will be break toward oxygen atom, so the carbon atom will get positive charge. So it is carbonyl. If we talk about this intermediate, it is unstable. Now nitrogen atom next to this carbonyl, it will stabilize this carbonyl by donating this lone pair of electron, and as a result double bond will be formed here, and it will be converted into imine. So this step is imine synthesis. With the removal of proton. And if we talk about the other component of this reaction, the third component of this reaction, which is 1,3-dicarbonylic functionality. Let's suppose we talk about the other the third component is 1,3-diketone. So this 1,3-diketone is in tautomeric form, which is converted into enol. And in this case, enol will attack at this carbon atom of imine, and as a result the bond will be break toward nitrogen atom and negative charge will be formed at nitrogen. Sorry, carbon. Here nitrogen, other part of the urea, and here negative charge. So here different types of proton is released in the reaction. Here also proton is released in the reaction, so then this proton will be accepted by this negatively charged nitrogen atom, so it will be converted into NH. In the next step, what will happen as the reaction is carried out in the presence of acid, so one of the carbonylic functionality of 1,3-diketone will be protonated. Let's suppose we consider that this carbonylic functionality is protonated. So what will happen? As we already talked about that this when carbonylic functionality is protonated, it becomes much more electrophilic in nature. So due to this reason, the other nitrogen atom of urea will attack at this carbonylic functionality, which is already protonated, and the bond will be break toward oxygen atom. And when the bond is break toward oxygen atom, it will be converted into OH, and this open chain will be cyclize. Here let's suppose here it is nitrogen, and this one is carbon. Here phenyl group is attached, and here 1 2 3. This is urea, this is NH phenyl. So here this one, so 1 2 and 3, so 1,3-diketonic functionality. So this part comes from 1,3-diketone. Okay, I will highlight this. So this part comes from 1,3-diketonic functionality, this part comes from urea, and this part comes from aldehyde or benzaldehyde. So as the reaction takes place in the presence of acid, so this OH will be protonated first, and by dehydration reaction double bond will be formed here. So the resultant product will be pyrimidone ring. So to understand this reaction, let's have a look to different example. Here cyclic 1,3-diketone is reacted with substituted benzaldehyde in the presence of acid, and the third component in this reaction is thiourea. As we talk about urea, so in this reaction, thiourea or urea react with this 1,3-diketone and benzaldehyde to produce substituted pyrimidone ring. In another example, in second example, here ketoester 1,3-ketoester is used, and here substituted benzaldehyde and urea. And in the first example here, HCl is used in the reaction because it is a acid catalyzed reaction. But in the case of second example, cerium chloride is used, which is Lewis acid. So the reaction is feasible in both protonic acid and Lewis acid. And if you talk about urea, so if you use urea, here carbonylic functionality will be formed, and if thiourea is used, thiocarbonylic functionality will be the part of this pyrimidone ring. I hope you enjoyed the video, and if you have any type of question, you may ask in the comment section. Thank you so much for watching the video. Thank you so much. Allah Paman.